In this video, I'm going to explain the standard error of mean and how to calculate it. First of all, we need to realize what the standard error of the mean is. It's basically the distance between the population and the sample mean, the expected distance. So we know that no matter how many times we take a sample from the population, that it's never going to be an exact duplicate of the population. There is going to be error, and the standard error of the mean, SEM, measures that distance. With that said, we have a set of data here, or parameters, because remember, any values that describe a population are parameters. We have population's mean of 10 and a standard deviation of 3, but if you notice, we have sample information, sample size of 9. So we have statistics and parameters both. So the question here is, what is the standard error of the mean? So what we want to do is go ahead and calculate this just straightforward the standard error of the mean equation. So the standard error of the mean equation is the standard deviation of the population divided by the square root of the sample size. Now if you notice, we're not using the mean, which is this population mean. That is always reported with the standard deviation. It doesn't make sense to report just a standard deviation. So sometimes you'll have information that you don't actually need. So to calculate this, we're going to just plug in that information. 3 divided by the square root of 9, right? To calculate that standard error of the mean. And if you plug that into your calculator, your answer that you should get is just 1. And I'm okay with you writing just 1 since how it's a whole number. But typically, if we have any kind of decimals, we should be using 2 decimals. So either way, if it is a whole number, you can keep it as a whole number. So our standard error of the mean is 1. Now we're going to look at kind of here, our standard error of the mean was 1. So right here, standard error of the mean is 1, just to go back, information in a different way. So now we are going to start looking at probabilities of finding specific means. So remember, the standard error of the mean is a measurement of the distance between the sample and the population information, and it depends upon what the sample size is. So when you get questions, you're going to be getting questions that's asking you to find a mean. So before you were using raw scores, but now you're locating means in a distribution. So here, what is the probability? So if you notice probability, that means we should be getting a p-value. So p equals, and I'm going to put question mark, okay, of selecting a sample mean. So that means we're going to be looking for m equals, right, of less than, and actually it wouldn't be equals, it would be, we want a mean that is less than or equal to 11. And I'm sorry, those aren't very dark, so I'll write them in red. P equals question mark, and m, because m is a sample mean, is less than or equal to 11. So here's kind of that information, just looking at the information from this problem. So the first thing that I recommend doing is drawing your distribution so that you can kind of get an idea of where you're going to be looking for that probability at. So if we look at our distribution, the population mean right down the middle is equal to 10. Well, 11 is a higher number than 10, so you know it's going to be over here somewhere, the mean. So I have m equals 11. But we're looking at of less than or equal to 11. So we're basically looking for the probability of this area plus all of this area over here. So we know that this area's p-value is 0.50 because half the distribution is 50%, and converted to a probability is 0.50. But now we need to find this area. So what we're going to look for is a p-value here. But we can't find that p-value until we find our z-score, right? So to get a z-score, we have to use our transformation equation to find a mean. So now instead of x minus the population mean divided by standard deviation, we're using m, the sample mean, minus the population mean divided by the standard error of the mean. So we end up with 11 minus 10 divided by 1. Because if you recall, so we're going to plug in that standard error of 1 there. So we end up basically with 1 divided by 1, which is 1. So our z-score is 1, and it's a positive 1, right? Because 11 is larger than 10. So z equals 1. And in your unit normal table, you're going to look for this chunk of information right here. That probability for right there. So the mean to z. So you're going to find the z-score of 1, and then you're going to look in that column B between mean and z, and this is in your unit normal table, and you'll notice the probability value is 0.3413. So let me get back to the pen. 0.3413. Now we want to add these two together to get the total proportion or probability. So P equals 0.8413. That's your final answer for selecting a mean of less than or equal to 11, that probability value. So one other couple of examples. So we can example problem. So here we have, what is the probability of selecting a sample mean of at least 12? So here again we have m is equal to 12, and it's actually probably equal to or greater than, because at least 12 is equal to or greater than. And now we want the probability value again, right? And that 12 is a mean. So ultimately we're looking for the p-value. So let's draw that distribution again, so we're making sure we're looking in the right places. So right down the middle is the population mean of 10. 12 is to the right of that, so somewhere over here. M equals 12. And we're looking at at least a sample mean of at least 12. So anything 12 or above, right? So the numbers will get higher over here. So to locate that, we need to get our z-score again. So we're going to plug that in. Z equals 12 minus 10. Remember, the sample mean minus the population mean divided by the standard error mean, which was 1. If you remember, we calculated standard error of the mean on this data set. 1 in there. And we ultimately end up with, 2 divided by 1. So there's 2. Okay, and that's a positive. So here, our z-score is 2. And then this area right here is the tail. So what we want to do is look up in that unit normal table a z-score of 2. And we want to look up in the tail because we're looking out beyond a z of 2. And your probability value is 0.0228. So P equals 0.0228. So that's the probability of selecting a sample mean of at least 12. Okay? So let's look at, just really quick, I'm going to add one on here. Let's say we're looking at finding a probability value, and I'm just going to short, of less than an average of 8. Okay, so probability value, that's that P equals, right? And now we want an average. If you use the word average, that's the same as mean, a sample mean, and 8. So M is less than 8. Okay, we're going to use the same information as before. So if you recall, before we had a population mean of 10, a standard deviation of 3, and the sample size was 9. And if you remember, we had calculated our standard error of the mean to be 1. So here's kind of our little template that we were going by. So as what we want to do is draw that distribution again. Right down the middle is our population mean of 10. And if you recall now 8 is less than 10, right? The sample mean of 8 is less than 10, so it's going to be to the left, right? So M equals 8. And we want to find a probability of less than 8. So we're looking in the tail, but we're looking in the tail at the lower end. So we're at Z equals, and we have 8, again, minus 10, right, divided by 1, correct? Well, 8 minus 10 is negative 2. Negative 2 divided by 1 is negative 2. So now our Z score, Z equals negative 2. And this is why I threw this in here, because your tables, of course, do not say negatives, because what's on the right is on the left. It's the same probabilities on both sides. The negative 2 just shows the location, saying it's below the mean. But you're still, when you look up 2, you're still going to look up in the tail. So again, this area is in the tail, and the area is still the same as the 10%, or I'm sorry, the positive 2 on the far side of the positive 2. The proportion is still the same. It's just an exact reflection. So the probability value beyond the tail is 0.0228. So 0.0228 again. It's just that negative 2 shows us that it's below the mean. Your probability value won't be negative. It's still a positive. Probabilities are never negative. Just think, if we converted this probability to a percentage, it would be 2.28%. You can't have negative 2.28%. So always remember, probability values should be positive. So that wraps up standard error of the mean. Hopefully this is a helpful video. Please do not hesitate to see me during office hours or email me questions if you have any. Thank you.